Welcome back, ladies and gentlemen, to Physical Science with Mr. Kenton. I'm going to be picking up where Miss Alexander left off with you guys by picking up with chemical properties. Now, just as a reminder, in this Properties of Matter unit, the thing that we're really focusing in on right now is our understanding and our ability to compare physical and chemical properties of matter. And so today we're going to focus in on and look at what are chemical properties and what are chemical changes. That should be the thing that you walk away from watching this video, and you should have a very good understanding of those two things. So with that, let's dive right in. You should see in front of you, it says chemical properties, and chemical properties are properties of substances, whether they're elements, compounds, whatever it is that we're talking about, that can be measured or observed only when matter undergoes a change to become an entirely different kind of substance or kind of matter. Okay, there's a lot to take away from that, but what I want you to understand is that in order for something to be a chemical property, you have to be able to observe it occurring, and you have to see that the substance actually changes to a different substance. Okay, this is different from our physical properties. Okay, and so you see the examples that have been listed here, the ability to rust. When you think about a piece of metal, when it gets exposed to water and oxygen, the metal loses its strength and it begins to flake off, right? It's no longer the same metal. Its properties have been changed because it's made up of different types of atoms now that are no longer the same. So it's not just one type of atom, it could be multiple types of atoms, or it could be a different atom altogether. In terms of reactivity, we don't know, for example, if we looked at a piece of zinc metal, it doesn't look reactive because when we touch it, it doesn't do anything. But when we place zinc metal in an acid, then we would be able to observe it being reactive by the gas bubbles that get produced when that zinc interacts with the hydrochloric acid. Inflammability. We don't know if something is going to catch on fire unless we place it in fire and see what happens. If it catches on fire, then it's flammable, and it's changing as we're doing that. As something's being burned, it's not staying the same. Its atoms at the particle level are changing into different types. Now, in terms of those chemical properties, we need to also think about chemical changes. And these are going to be things that you and I can observe that can let us know that those chemical properties are in fact being observed, right? And so it says that chemical changes occur whenever matter changes into an entirely different substance with chemical properties. Now, if you think back to what Miss Alexander went over with you guys, a substance or a pure substance is something that's either an element or a compound. Now, elements are made up of one type of atom. They're on the periodic table. And your compounds have more than one of those atoms within a particular structure. Okay, and so a chemical change occurs when those substances are changing into different substances. Now, for our purposes, a chemical change can also be referred to as a chemical reaction. Okay, and there are lots of different types of chemical reactions. You've got synthesis, you've got decomposition, you've got combustion, single replacement, double replacement. But these are all things that are helping us to observe and make predictions about chemical changes that are taking place at the particle level. Okay, again, to reiterate this, because this is extremely different from our physical properties, chemical changes is when a pure substance changes into a different pure substance. And again, pure substance, element, compound. So one element or compound changes to a different element or compound, right? And the following are indicators of a chemical change. So these are things that when we are watching a chemical process or a chemical change take place, these are things we should be able to see. First thing you have listed is the formation of a gas. And so if you think back to the example I mentioned on the previous slide with zinc and acid, when zinc is placed in an acid, gas bubbles form, hydrogen gas is formed. And so that would let us know that a chemical change is taking place. The second thing we have is change in temperature. So you could think about like hot packs or cold packs. What happens is that two aqueous solutions, which that just means two compounds that have been dissolved in water, when they mix, sometimes they get really warm, sometimes they get really hot, but that change in temperature is indicating that a chemical change has taken place. Thirdly, you've got forming a precipitate. Now again, taking those aqueous solutions, if you mix them, sometimes something that mixes with them doesn't stay dissolved, and so that solid, that precipitate, falls out of that liquid and settles at the bottom. So that's a precipitate. You've got light energy, so some reactions when they take place, large amounts of light are produced. And then lastly, you've got a color change. And I want to emphasize here, this is not the same thing as if you were to take a piece of paper and you were to color over it. I'm thinking more of like in the precipitate example, most of the time your solutions might be translucent so you can see through them. But then when you mix them, what could happen is that the solid that forms is also a very different color, and so it no longer becomes translucent. You could get solutions where you mix two clear liquids and then all of a sudden it turns very yellow. Okay, and so these color changes are taking place, and all of these things that we just mentioned are just indicators of a chemical change. Now, to reiterate and to kind of finalize this to give you guys some practice, I want you to take a look at the following examples. Okay, so I want you to identify each of these situations as either a physical or a chemical change, right? And keep in mind, what's the difference between physical chemical changes? Feel free to look back at your notes, use those to help you answer those questions, and then we'll talk about them as a class.